we're going to sum up everything we know about e to the x and ln of x. So remember that e to the x and ln of x are inverse functions. Okay? And when we look at the graph, here's e to the x, here's ln of x. And inverse functions are going to reflect over this line y equals x, which is what we have. So everything here is looking really good. And what I'd like to do is go through the domain, the range, the asymptotes, and those kinds of things. So let's start with e to the x. The domain of a function is all the x values we're allowed to put into the function. So in this case, I can put in negative x values, I can put x equals 0 in, I can put positive x values in. So my domain is going to be all real numbers. And the values that we get out, so the ranges are y values. Okay. So we don't have any for e to the x. We don't have any negative y values. We don't have 0, but we do have all these positive y values. So the range on e to the x is y is greater than 0. And for natural log of x, let's look at its domain and range. So natural log is this red one. We don't see natural log of x in the negatives or at 0. The domain, the x values we're allowed to plug into natural log are any x's greater than 0. Okay, so that's kind of what we learned from the previous page looking at that. And then our range are the y values we can get out. And I see negative y values, I see y is equal to 0, and I see positive y values. So that covers pretty much everything there is. Negative y's, positive y's, y is 0. So our range is all real numbers. Our horizontal asymptote, so a horizontal line goes this way, and it's going to have the equation y equals something. So let's look at e to the x. So as I move along here, is there a spot where it looks like my function is going to get really close to a horizontal line? And there is. Okay, so we look at this tail end of e to the x over here. We see that it's getting really close to the x-axis. Okay, or in other words, y is equal to 0. And for natural log of x, there is no place where that function levels off and kind of gets just really close to an asymptote and doesn't cross it, because really ln of x is just going to keep growing. That's what we have reflected here. So there are no horizontal asymptotes for that natural log of x. And then vertical asymptote, so a vertical line goes this way. And I don't see any place where e to the x has a vertical asymptote. But on natural log of x, this left side tail of that function sits right here against the y-axis, which is x is equal to 0. So your vertical asymptote is going to have that equation x is equal to something. All right, and then last but not least, let's look at the concavity and how the rates of change are increasing or decreasing as we move across our function. So let's start with e to the x. What I see here is I have half of a bowl. So that tells me that my function is concave up. And those rates of change are small, getting bigger, getting, whoa, really, really big. Okay, so as we move from left to right, okay, our rates of change are going to increase. They're going to get bigger. And then let's look at how that works with natural log of x. So as I move along here, this is really steep here. These are going to be really big rates of change. As I get over here, it starts to level off a little bit. So smaller rates of change, smaller, smaller, still getting ever smaller rates of change here. So our rates of change are going to decrease in value as we move from left to right. And concavity, this looks like half of an umbrella, which is going to make this concave down. And now we're going to use that information to figure out the domains of the following functions. So we'll start with y is equal to natural log of x squared. So we know that whatever is in here needs to be bigger than 0, or we're going to run into a domain issue here. So I need x squared bigger than 0. And that's going to happen if I take the square root of both sides when x is bigger than 0. Okay. And then let's look at y is equal to ln of x squared. Let me move that up a little bit. All right, so I know from this ln of x part here that x needs to be bigger than 0. And then I can square any number I want. So it doesn't really matter what comes out of the ln of x. I can always square it. So that means that my only restriction on the domain here is just simply x is greater than 0. All right. I have ln of x. So you like these composition of functions, these nested functions. So what I need is this inside guy here, ln of x, to be greater than 0. So whatever ln of x outputs needs to be bigger than 0 so that I can take the natural log of that again. All right, so to solve this, I know that ln and e are inverses. So e to the ln of x has to be greater than e to the 0, which means that x has to be greater than 1, because anything to the 0 is 1. So there's our domain there, and then one more. ln of x minus 3. So you might be able to do this one on your own now that we've done, especially this one, and tried a couple of these. So think about that for just a second and see if you can work that one out. Okay, so ultimately what you want to do is take x minus 3 and say that needs to be bigger than 0. Because as long as that's bigger than 0, you can plug that into the natural log and get an answer out. And if we use algebra to clean that up a little bit, we just get that x is greater than 3. So if I put in any x bigger than 3, that natural log function will be defined and we'll be able to get a value there.